Formula One is built on some of the most tightly controlled technical regulations in motorsport. Every wind tunnel session, every CFD simulation, and every hour of aerodynamic development is carefully monitored to keep competition as fair as possible. But what if a team's biggest advantage doesn't come from bending the rules? It comes from working alongside a partner that operates entirely outside Formula One's regulatory framework. That's exactly why the growing relationship between Toyota Gazoo Racing and Haas has become one of the most intriguing stories in the paddock. Officially, it's a technical partnership focused on engineering collaboration and talent development. Yet, many observers believe it could represent something even more significant. A glimpse into how modern engineering alliances might reshape the competitive landscape without ever crossing a clearly defined regulatory line. To understand why this partnership has attracted so much attention, it's important to understand how Formula One controls aerodynamic development in the first place. Unlike many other forms of motorsport, success in modern F1 isn't simply about building the fastest car. It's also about deciding where and how to spend an extremely limited amount of development time. The FIA's aerodynamic testing restrictions, commonly known as the ATR, are designed to prevent the wealthiest teams from overwhelming the competition through unlimited research. Every Formula One constructor receives a fixed allocation of wind tunnel testing and computational fluid dynamics (CFD) simulations during specific testing periods throughout the season. The system is intentionally unbalanced in favor of teams lower down the championship standings. Constructors that finish near the front receive fewer aerodynamic testing opportunities, while teams further back are granted additional development time. The objective is straightforward: reduce the performance gap across the grid and create closer racing over time. These restrictions work alongside Formula One's cost cap, creating a development environment where efficiency often matters more than raw spending power. Teams can no longer rely on endless experimentation. Every wind tunnel session has to answer a specific question, and every CFD simulation must provide meaningful data. That reality has changed the way engineers approach car development. Instead of testing dozens of different ideas and hoping one delivers a breakthrough, teams spend months analyzing concepts before committing valuable ATR resources. A single unproductive development program can consume a significant portion of a team's available testing allowance, delaying upgrades and affecting performance for multiple races. In today's Formula One, the greatest competitive advantage isn't necessarily having more resources, it's making smarter decisions with the limited resources the regulations allow. That is why any partnership capable of improving engineering efficiency naturally attracts attention throughout the paddock, even when it operates within the existing framework of the rules. Toyota may not currently compete as a Formula One constructor, but its absence from the grid should not be mistaken for a lack of technical capability. Few manufacturers in global motorsport possess the engineering depth, research infrastructure, and aerodynamic expertise that Toyota has built over decades of competition. At the center of that reputation is Toyota Gazoo Racing Europe in Cologne, Germany. Originally developed during Toyota's own Formula One program in the 2000s, the facility has remained one of the company's most advanced engineering centers. Rather than becoming obsolete after Toyota left Formula One, it evolved into a hub supporting multiple high-performance projects across international motorsport and automotive research. Today, Toyota competes at the highest level in endurance racing through the FIA World Endurance Championship, where aerodynamic efficiency plays a critical role over races lasting 6, 12, and even 24 hours. Success in that environment depends on extracting maximum performance while maintaining stability, tire management, and reliability under constantly changing conditions. Those challenges are different from Formula One, but many of the engineering principles are remarkably similar. engineers still study airflow around the car, optimize underbody performance, reduce aerodynamic drag, and search for greater efficiency through countless design iterations. The tools, simulation methods, and validation processes used in these programs represent years of accumulated knowledge. This is what makes Toyota such a valuable technical partner. Beyond physical facilities and equipment, the company brings an enormous pool of engineering experience. Thousands of hours spent solving complex aerodynamic problems have created expertise that cannot simply be measured by wind tunnel time or computing power alone. As Formula One becomes increasingly dependent on collaboration between manufacturers and specialist engineering organizations, partnerships like the one between Toyota and Haas demonstrate that competitive advantage can come from far more than financial investment. Sometimes the most valuable resource is access to people who have already solved similar engineering challenges in other forms of elite motorsport. This is where the conversation becomes more interesting. The debate surrounding the Toyota-Haas partnership is not centered on whether regulations have been openly violated. Instead, it focuses on how Formula One's rules apply when knowledge and expertise move between organizations that operate under different regulatory frameworks. Formula One's aerodynamic testing restrictions are written specifically for championship entrants. Every constructor must account for its own wind tunnel usage, CFD simulations, and aerodynamic development within clearly defined limits. Those activities are subject to FIA oversight, with teams required to document and report how their testing resources are used. Companies outside the championship, however, operate under different circumstances. Manufacturers involved in endurance racing, road car development, or other engineering programs conduct extensive research for projects that have no direct connection to Formula One. Their facilities, personnel, and development schedules exist to support their own commercial and motorsport objectives. This creates an important distinction. While Formula One regulations tightly control how an entrant develops its own car, they do not prevent independent companies from continuing legitimate research for unrelated programs. The challenge arises when those companies also maintain technical relationships with an F1 team. That does not automatically imply that restricted Formula One data is being exchanged. In fact, FIA regulations contain strict rules governing intellectual property, listed team components, and the transfer of protected design information. Any direct sharing of prohibited aerodynamic designs or confidential F1 data would carry serious regulatory consequences. However, engineering collaboration is rarely limited to the exchange of digital files. Teams routinely benefit from discussions about manufacturing techniques, testing procedures, project management, simulation methods, and broader engineering philosophy. These forms of collaboration are common throughout modern motorsport and are often entirely permissible under existing regulations. This is why partnerships like Toyota and Haas generate so much interest across the paddock. The discussion is less about identifying a specific loophole and more about understanding where technical cooperation ends and competitive advantage begins. As Formula One becomes increasingly interconnected with major automotive manufacturers, that distinction is likely to receive even greater attention from rival teams and regulators in the years ahead. When people think about technical collaboration, they often imagine confidential design files or detailed CAD models being exchanged between organizations. In reality, one of the most valuable assets in motorsport is something far less tangible: engineering experience. An experienced aerodynamicist doesn't need to transfer a digital blueprint to influence a project. Years of working on high-performance race cars develop an instinct for recognizing promising concepts, identifying potential weaknesses, and knowing which development paths are unlikely to deliver meaningful gains. That knowledge travels with the engineer, not with a computer file. This is one reason why personnel exchanges have become increasingly common across Formula One and the wider motorsport industry. Engineers move between manufacturers, suppliers, and racing programs, bringing with them new perspectives, problem-solving approaches, and lessons learned from previous projects. While they remain bound by confidentiality agreements and intellectual property rules, their professional experience naturally shapes the decisions they make in future roles. For a team operating under strict aerodynamic testing limits, that experience can be incredibly valuable. Wind tunnel time and CFD simulations are limited resources, meaning every development program must be carefully prioritized. Engineers who have previously worked on similar aerodynamic challenges may be able to identify which concepts deserve immediate attention and which ideas are unlikely to justify the investment. This doesn't eliminate the need for Formula One testing. Every design still has to be validated using the team's own approved development process, and every aerodynamic component must comply with FIA regulations. However, entering that process with a stronger understanding of the underlying engineering principles can make development significantly more efficient. In practical terms, this means fewer unproductive experiments, faster refinement of promising ideas, and better use of the limited testing allocation available throughout the season. Rather than relying on trial and error, engineers can focus their efforts on concepts with a higher probability of success. That is why partnerships involving experienced manufacturers attract so much attention. The greatest advantage may not come from additional facilities or equipment, but from the accumulated knowledge of engineers who have spent years solving similar technical problems in other top-level racing categories. In modern Formula One, expertise is often the resource that delivers the biggest competitive edge. The key question is whether this partnership could help Haas accelerate its rate of development. While no outside organization can bypass the FIA's technical regulations on behalf of an F1 team, access to broader engineering expertise can still influence how efficiently a team approaches its own development program. That possibility is especially relevant under the current ground effect regulations. Since their introduction in 2022, the floor has become the single most important aerodynamic component on the car. Small changes to its geometry can dramatically affect downforce, balance, and tire performance, but they can also introduce instability if airflow behaves differently than expected. Developing these floors is an exceptionally complex process. Engineers must understand how the car reacts through different ride heights, cornering loads, braking zones, and track surfaces. Even minor variations can alter airflow underneath the car, making it difficult to predict real-world performance using simulation alone. For larger teams with extensive technical resources, solving these problems is challenging enough. For smaller constructors, the task becomes even more demanding because every wind tunnel session and CFD run must be used as efficiently as possible. There is far less room for experimentation when development opportunities are limited. This is where experienced technical partners may offer meaningful value. Engineers who have spent years working on advanced aerodynamic projects, whether in endurance racing, prototype development, or other high-performance programs, can contribute proven analytical methods and a deeper understanding of complex airflow behavior. Their experience may help identify promising concepts earlier in the design process, reducing the number of unsuccessful ideas that reach formal testing. That does not mean performance gains are guaranteed. Formula One remains one of the most technically demanding championships in the world, and every team faces unique design constraints. A solution that performs well in one category cannot simply be transferred directly to an F1 car without extensive validation. Even so, improved engineering efficiency can make a significant difference over the course of a season. If a team consistently spends its limited development resources on stronger concepts, upgrades are more likely to reach the circuit sooner and deliver measurable performance improvements. In a championship where fractions of a second often separate multiple teams, That kind of efficiency can become a genuine competitive advantage. Whether Toyota's partnership ultimately produces that outcome remains to be seen, but it illustrates how Formula One's competitive edge is increasingly defined not just by budgets, but by the quality of the engineering network supporting each team. Whether the Toyota-Haas partnership ultimately changes the competitive order or not, one thing is certain: rival teams are watching closely. In Formula One, innovation rarely goes unnoticed, especially when a smaller constructor begins making noticeable progress against better-funded competitors. Every leading team employs specialists whose job extends far beyond designing race cars. Alongside engineers, organizations maintain departments focused on regulatory compliance, technical analysis, and competitor research. Their role is to study new developments across the grid, understand how rivals are improving, and determine whether every advantage falls within the regulations. When a team introduces a series of effective upgrades in quick succession, questions naturally follow. Has it discovered a breakthrough design philosophy? Has it improved its internal development process? Or has a new technical partnership accelerated its learning curve? These are the kinds of discussions that frequently take place behind closed doors throughout the paddock. The Toyota-Haas collaboration also highlights a broader trend within Formula One. Modern teams are becoming increasingly connected to global manufacturers, technology companies, and specialist engineering firms. Success is no longer determined solely by what happens inside a single factory. Instead, it often depends on how effectively organizations combine expertise from multiple disciplines while remaining within the sport's regulatory framework. As these partnerships become more sophisticated, the FIA may face growing pressure to review whether the current regulations still reflect the realities of modern motorsport. Existing rules already govern intellectual property, listed team components, and aerodynamic testing. But future discussions could focus on how technical knowledge moves between collaborating organizations and whether additional guidance is needed. At the same time, regulators must balance competitive fairness with the collaborative nature of the industry. Formula One has long relied on relationships with manufacturers, suppliers, and technology partners to drive innovation. Any attempt to place excessive restrictions on engineering cooperation could have unintended consequences, potentially limiting the exchange of expertise that has helped advance both motorsport and automotive technology. For rival teams, this creates an interesting dilemma. They want regulations that ensure a level playing field, but they also benefit from their own commercial and technical partnerships. Finding that balance will likely become one of the sport's most important political discussions as Formula One continues to evolve. Formula One has always rewarded innovation, but today's battles are no longer fought solely through bigger budgets or larger factories. Increasingly, success depends on how effectively teams combine engineering talent, technical partnerships, and efficient development within an increasingly complex regulatory environment. The relationship between Toyota and Haas reflects that shift. Rather than simply asking who has the most wind tunnel time or the largest research budget, the conversation is expanding to include who has access to the deepest pool of engineering expertise. In a championship where every development cycle is tightly controlled, experience and collaboration can be just as valuable as additional resources. It's important to recognize that there is no public evidence that Haas or Toyota have violated Formula One regulations. Their partnership operates within an established framework, and any competitive advantage would still need to be realized through Haas's own development process under FIA oversight. Nevertheless, the collaboration has sparked an important discussion about whether the sport's current rules fully account for the increasingly interconnected nature of modern motorsport. If partnerships like this continue to grow, the FIA may eventually need to revisit how technical collaboration is regulated, not to discourage innovation, but to ensure the competitive balance remains consistent with the objectives of the cost cap and aerodynamic testing restrictions. For now, the Toyota-Haas alliance represents more than just another commercial agreement. It serves as a reminder that in Formula One, the next competitive breakthrough may come not from rewriting the rulebook, but from finding smarter ways to work within it. As the sport enters a new era of engineering collaboration, the teams that adapt fastest could shape the next chapter of Formula One's competitive landscape.